Okay, let's take a look at a codominant Punnett square. In a codominant Punnett square, what you see is that both alleles are expressed in the trait. One of the classic examples that they like to use in basic Punnett square problems involves horses, where we could use big R to represent red hair and little r to represent white hair. So big R would give you a red horse, little r would give you a white horse. But when both are present and it's heterozygous, big R, you see a presence of both hair colors, what they call roan horse. Now this might be a little simplistic for horse genetics, but we'll go ahead and use it as a couple examples of codominance. Let's say that we had a horse who was red. So big R on both alleles, and a horse that was white, little r. If we cross those two with a Punnett square, big R, little r, big R, little r, big R, little r, and big R, little r gets filled into each square, which means that all of the genotypes, or 100%, are going to be big R, little r, which means our phenotype is going to be 100% of both alleles expressed, or a roan horse. We could do another example where, let's say, our individual instead was a heterozygous individual, a roan horse, and we cross them with, let's say, a white horse. So we'll put one parent on the top. Let's put the white horse on the top, and another parent on the side. Let's do the roan horse. We fill out our Punnett square. And what we see is that 2 out of the 4 boxes are big R, little r. I'll express it as a fraction this time. So 1/2 are big R, little r, and 1/2 are little r. When we go to look at our phenotypes, what we see is that 1/2 of the children, or there's 50% chance for each child that the child will be roan, and a 50% chance that a child will be white. It certainly does not mean that if they have one roan child, their next child is for sure going to be white. It's a 50-50 chance each time they have a child. So that's an example of codominance.